Hello and welcome to today's session on parallel versus simple for each. So I have taken the below measure to compare between simple and a parallel for each activity. This is the theory which we are going to discuss after our practical sessions. So for this session, I have already opened Uipath Studio and taken this sequence, called it a simple for each. Okay. So here I'm going to take a for each activity. I'll be creating an array from 1 to 5. In this, I'm going to take two right line activities. And then I will be taking a delay activity. We'll be discussing what are this activity going, how are they going to help us. To convert it to a string. And this is the end. Okay. Okay. And we need to give a timestamp here. I am taking a delay of 2 seconds. Okay, you're good. So what I have done here, I have created an array of 1 to 5. In the very beginning, I have taken the count, I have displayed the uh, uh, item value here, and before that I have taken a prefix of begin. Imagine that this delay is nothing but a long running activity which is going to be a real time scenario. Okay, now the end one is nothing but it is going to denote that your process has ended here, and this is the last step which you have performed. Okay, so I will just debug this by pressing F6, and you will be able to see the output how it is coming. So started with 1, begin 1, end 1, begin 1, end 1, and it is taking enough time. It is taking a delay of 2 seconds in between each of this. Okay, I will just show you again that how it is looking. Okay, now similarly we can create a parallel for each activity. So I can just copy paste the same sequence, and I am just going to replace only one thing out of it. Instead of using simple for each, I'm going to use a parallel for each activity. Okay, and then I will go back to our old code. I will copy the body which is present in the existing for each loop. I will paste it here. I will replicate the same array which we built. I will call it parallel for each, just renaming the sequence. And then connecting my start with this sequence. Okay, I'm just going to repeat whatever we have done till now. We have used a simple parallel for each activity, created an array inside it. The first step which we have done is right line and going to show the value of item. Then there is a long running task, which is nothing but the delay in our case for simplicity of 2 seconds. And then in the end, to denote that this process has been completed, a simple end with which item has been finished. Okay, so I am pressing F6 and we will see how uh, it is going to show different output from a simple for each activity. So you can see all begins executed so quickly. Okay, I'm just opening this. Okay, all begins showed up all together very quickly. Then all the ends. Okay, what happened in the background? The begin five, when the begin five thread was basically when the process started, the first thing which was picked was begin five. A new thread started, and then there was a delay of 2 seconds. The thread went on uh, or delay, or you can say that the thread was going to execute a long running process. Okay, and then the next thread started that picked up the fourth item, then the third item, second item, the first item. Now the delay of 2 seconds was already over. So the thread number five, which has finished its long running task, has completed the end or the last activity which was present in the for each loop. Similarly, 4, 3, 2, 1. Okay. In the real time scenario, you may end up seeing this end is coming before all the begins have finished. What I'm trying to say here is it can come anywhere. The threads can start executing a specific process and they can finish even before uh, number five is getting finished, right? So there is no sequence when this process is going to start or when this process is going to end. Even the begin number three can even start before begin number five. Okay, thread it completely depends on the thread and how the Microsoft is handling that specific thread. Okay, so we'll go back to our theory discussion. Okay, so execution, as we have already seen, that a simple for each was sequential. It executed the process one by one. Okay, there was no jumbling here and there, and the threads, there was no threading basically. So it was a single thread which was executing each and every step and each and every iteration in the for each loop. Whereas in case of parallel for each, there were five different threads. Since we had five different elements in the array, there were five different threads which were invoked and which were assigned to complete each execution of parallel for each. Okay. Now the use cases. When to use what? Good, as I mean, good for dependent and sequential execution in case of for each. In case of parallel for each, it is good for long running and independent processes. So what is dependent and independent here? Let's say in the first thread, you are going to use a resource. Take an example of a simple Excel sheet. Okay. In the first process, you are going to increment something in that specific Excel sheet, or you're going to add some values in it. When next iteration is coming, you are again going to read that value. Okay, so which is dependent on the first execution. So if it is a for each activity, it will go sequence by sequence. But if it is a parallel for each, you don't know which thread will come first and which thread will come second. So if you want to use the same resource or you are updating the same resource, then in that case, you should make sure you are not getting confused between which uh, for each you should use. Now, with respect to time, how which activity is better and which is slower, faster and slower. So it is not faster. We cannot directly say that which one is faster and which one is slower. We'll take a simple real-time example of a, let's say you are a architect in a company and you are assigned to review five different processes, five different UiPath processes. Let's take a simple example that you are going to spend 1 hour for each process to finish the review on an average. Okay, then you are going to spend total 10 hours. But you thought, why should I spend 10 hours? I will go and look for uh, a different resource and ask. I will assign him five processes, and I will do five processes. Okay. So you went on and you found a resource, but that process took 5 hours for you. Okay. And then you gave him the remaining. I mean, you gave him the five processes, and you yourself took five processes for review. So how much actually you spent? You yourself spent 5 hours to review the processes, 5 hours to find the resource who can basically review the remaining five processes. And that resource he himself spent around 5 hours. So that totally it is 15 hours, right? But since it is parallel, it is going to be faster. I mean, in this case, we are not seeing advantage. But take an example when you have 100 processes, right? If you are going to do it by yourself, you are going to take 100 hours. But let's say you have you actually went and looked for a resource which where you spent 5 hours, right? So now you are going to uh, complete this process, the entire process in 55 hours, right? But imagine a situation when you can basically look for n number of resources and you can assign each of this activity parallelly. The numbers will keep growing, the processes will keep going, and we can have a number of threads, right? A number of resources. So yeah, so in that those scenarios, it is always better to use parallel for each. But when you have a simple, straightforward processes where the inputs are dependent on each other, and each execution or each iteration is dependent on the previous iteration, in that case, you should definitely prefer to use a simple for each one. I hope this made some concepts clear for in difference between a simple for each versus parallel for each. Thank you.